at the Injection Molding and Design Expo,
Once again, thanks
Novi,
again for
Michigan.
being very informative presentation there. The Alcogen booth
Decided to get out of the house
is just
and
directly next to the
go to the
theatre there.
Expo.
You can't miss it.
We
Colourful
got
blue one there. The booth number is
lecture
1323. So we have another industry presentation
Henry
taking
Ford, if
place
you need a machine.
soon after this one. So it will be at 2 o'clock. So if you stick around, that will take place just shortly. Okay, thank you.
Okay, so thank God this one's a smaller show than the battery show. Battery show is one of the biggest ones of the whole year. But the injection molding design is extremely important. So I also kind of wanted to talk about the UAW strike. I figure it's probably the best venue to talk about from convention center floor. Manufacturer, get a feel for what's going on. Most of my insight, heads up on the industry, is coming to these conventions, and also gather some reading material. And so just a few random quick thoughts on injection molding. So manufacture
This interface
into a lot of detail. People call my streetels, and you have what's called additive manufacturing, which is engineering, where you take a bigger piece and mold what you want out of it. So you're like sculpting, like CNCing, cutting, any of the various methods where you start with some sort of material in a larger form, and then you cut it down into exactly what you want. Molding, as I mentioned last year, like the old, the crucible and old metal molding. It's also one of the ancient manufacturing processes, like for the original metal molding, where they have rocks and they heat up metal or iron or copper, like the Copper Age, the Iron Age, and they would chisel, make some sort of shape. It's considered like a sword or pottery or some useful object, a spear tip, and then they would heat up the metal, and then they would pour it into the concrete, let it cool, and then extract the piece. So you could consider that injection molding. And even through like the Renaissance and a lot of sculptures and various things, mostly like swordsmanship tools, like the plow, various things use some sort of injection molding. However, injection molding vastly changed in the last few hundred years, and you have all sorts of plastics, the advent of plastics, and like lithium. They have a lithium show coming, and various materials from originally molding was mostly from the guilds. It was mostly from like smiths, and it was mostly metal. And it's not really considered injection molding, the old school, what they did hundreds of years ago to like make swords and pots. So what did change was machinery, industrialization, and plastics, material sciences, Lavoisier and the discovery of the periodic table, and material chemistry and various aspects changed. And you also like steel and you just material sciences, chemistry, that completely changed, and we had precision materials. And so let's see if we can look at this machine. So you have like a mold here, and these are metal, and the concept is very simple. You have a mold, it has a shape, it has a small amount in the shape, and some sort of material is heated to a temperature where it's liquid or liquefied, and then it's extruded into the shape, and then these are new machinery. They cool very quickly. They can make many parts, and then the piece is removed, and another one goes in. So depending on the material. So this is a huge machine, and even for the old, think of like metal or something like that, where you had to have thousands of degrees, huge. Hey Billy, God bless, good to see you. Yeah, the old days where you had huge fires and they had to melt metal. To here where you have specifically prepared materials, they have the specifications, the exact know-how of how hot they have, how much time do they have to let it cool, and where you could have a process where you could have millions of parts coming out, one after the other, where it's a few seconds. So injection molding, although it has ancient origins, and it was one of the main manufacturing processes going back to the Iron Age, the Copper Age, has vastly changed in the last 150 years with the Industrial Revolution and the creation of machines and the discovery of material science, the periodic table, and so now you could have determined from science and chemistry the exact properties of materials, exact temperatures, physics. People have been watching Week in Review in my philosophy of science. The measurement science, where you have equations that make exact predictions through mathematical equations. So you could, all of these machines operate according to exact mathematical principles, where you could determine exactly what temperature the element needs to be at, how long it's going to take to dry, how strong it's going to be afterwards, and even estimated life, wear and tear. So just a little philosophical, scientific background. So nowadays, probably I don't know the numbers. I didn't prepare. I have to look in the magazines, get the reading material. But I wouldn't be surprised if about half of the manufacture is injection molding. 3D printing now is less than 10%. The majority manufacture process is in fact injection molding. The majority of injection molding is plastics, is low temperature. And plastics could be a generic term like foam. What does it mean, foam? Went to the foam show this year. Foam is simply anything that has air inserted to it. So you could have like aluminum foam, as long because it's considered foam as long as it has air inserted into it. So also what is plastics? Plastics is some sort of carbon-based chemical, oil, sometimes oil-based, hard to define. You can have materials like lithium or various elements, but most injection molding is low temperature things like plastics that melt even less than water. And so the process is rather simple, very similar to a 3D printer, except you have the shape of the object you desire. You melt the material, put it into the form, and then you separate the form, take the shape out. And it's actually very complicated. So, Orfeo, God bless, thanks for tuning in. The details of injection molding are very complicated. So you could make your own task model So like injection molding is something you could do in your house. So here they have like pellets, plastic pellets, or various things. They got like nice, the type. You could buy amount of material. You could make your own mold. Depending on what type of material. You could do a concrete mold, a metal mold, a wood mold, or, just depending on the temperature, as long as the temperature of the object. But so like 3D. A lot of times it'll be like a board game. You want to make a board game piece. So you have a design, you make your first one. You can do it any method with a knife, but we do that by various methods. Like nowadays, you 3D scan it, and then you could 3D print the mold, or you could have it designed, like concrete. More simple forms, you could use some sort of. Usually, it's a multiple process, so you'd have to use material over material. So if you have, let's say the object that you want to make, you would have to cover it with another object, remove the object, and eventually get a harder and harder mold until you could have the mold, like a concrete mold. And all these concrete molds, thing that then you inject your production, thousands, hundreds of thousands of pieces, where you can make hundreds of thousands a month. The mold is replaceable. So you would usually go to a company that specializes in making the molds. They're usually going to be made of some sort of metal or steel, like this. So, I don't know if this was making bowls or something. I don't think they're actually making anything here. But if it was some object, that metal piece inside there would be a mold. You would have that design, and then you could reconfigure the machine. So, this is a huge machine that probably costs hundreds of thousands, even millions of dollars. Although you could get a molding machine for as cheap as, I think $150,000. Here they have a chest around a steel chest set made of nozzles and extruders. Pretty cool, they're all hovered around it. But I think last year when I went to the injection molding, I saw that you could get an injection molding machine for as little as $150,000, and it would be reconfigurable. So it would have a range of materials that would be able to be inserted into it, where you would be able to a whole range of plastics or lithiums or polymers or whatever that would be able to be inserted to it, and then you would have the box, the insert that would also be insertable, and then likely you would pay a company. So like that metal piece in there that would be actually your mold, that might cost thousands to tens of thousands of dollars. So if you were making multiple pieces, the mold that would go in the molding machine would cost thousands to tens of thousands of dollars, and you would likely pay a company to make it for you. You would have a prototype, and they would go through their process to make your mold for you. So that's what you have here. You have all the various supply chain for injection molding, from the design companies, the supplier companies, the polymers, the plastics, the metals, the companies that make the molds, the companies that make the machines, the design companies, engineering. So it's not a huge show, relative to the battery show, but there's over 50 people. It's tomorrow also, so anyone here in Metro Detroit, you come check out tomorrow also the injection molding show, and some of the machinery, pretty cool stuff. There you can see the smaller machine. So here the BLE is a huge machine. Here's a smaller machine, an even smaller machine that all use the same process. And
I'm sorry, man.
Oh, no problem. So I was, reading the Elon Musk book, and when they made the electric car, he wanted the bottom of the electric car to be one piece. That they would manufacture in the very, the bottom of the electric car would be made in one piece. So at that point, they didn't have a machine big enough to do it, and they had to find an Italian company in a huge piece that makes in one part the whole bottom of the Tesla electric vehicle. And I'm not sure if that's aluminum or steel, or it might be some patented alloy, like aluminum, steel, or something like that. And it could be it's a form of injection molding. My guess is it's injection molding, although for that they might call it a different process. So let me talk a little bit about the UAW strike, because it looks like it's going to carry on. And I go to a lot of these conventions, and you can see a little bit about the breakdown of American society, the manufacturing processes, and unions, general labor in general is God forbid, what is your part in the labor market? And so you come to these shows, the economic background is largely designed in a way like all these people here are basically sales. You have engineering, and then if you actually needed labor would be like the last aspect, and you might go for cheap. So on a factory floor for injection molding, you have the business side and the engineering side and the sales side. The labor side is very minimal. So operating a machine like this, you might have a technician, like the company would have a technician that would upkeep the machine and the supply. But in terms of labor, I worked in a metal stamping plant after high school for a few weeks in the summer, and it was really boring. I made boxes, I sat at a machine, every few minutes the machine popped out a part, and I took the part and I put it on the rack, and then when the rack got full, I called over the person to take the rack away. And when the machine was down, I was making up boxes. So if you were doing injection molding, there might be certain labor parts of it that would be technician style labor. You might have an engineer doing it, but it would be a race to the bottom for low skilled labor. I mean, you might call it high skilled labor, but uncertified labor. And it would somewhat be zero sum, where you would probably want to pay as little as possible to get the best job done. And here you can see another example of the reconfigurable part that would go inside for the mold. So like the auto industry, now they mostly operate like as a bank. So like General Motors, Ford, because they do their own financing. Like GMC, their stock price, they're more like a bank actually. But the aspect of sales, design, business, marketing versus the actual labor. And so, the UAW, for the big plants, there's still enough labor to be unionized. So Elon Musk, Tesla has avoided unionization. Most manufacturer on the injection molding side is not going to be unionized. There might be a few companies that, let's say, had hundreds of these machines and hundreds of employees, and the labor side is probably pretty shoddy. Like if you're on the labor side of any of these machines, you're probably getting paid very little, maybe even the low tens of dollars, and you're without benefits, and it's a tough job market. Almost no one here at this convention is on the side of labor. Everyone here is in engineering, design, and sales. And I would guess almost none of these companies are unionized, and it's unlikely that any of these companies would be big enough to be unionized. However, many of these companies are involved in the supply chain. Like I've said many times, manufacture is automotive or bust, because the automotive industry represents over 50% of the global manufacturing market. So, over half of all manufacturing companies are involved in the automotive industry, and that's the main reason why these conventions are in Detroit. The injection molding is not automotive specific, but because automotive is the biggest market, that's the reason these shows in Detroit. That's why people from all over the world, companies show their machinery, because Detroit is still probably the single largest base of manufacturer. So the UAW, representing Ford, GM, and Stellaris, the new Chrysler company, are really the only unionized. Tesla's not unionized. Most of the Asian automatic like Hyundai, Toyota, even like BMW, German companies, most of them manufacture in America also. They're not U.S. companies. They're Asian or German companies. However, they have final assembly or plants here in America. Almost none of those are unionized. And very few to none of the suppliers are unionized. The only thing that's unionized left is Northeast companies directly involved for GM, Ford, and Stellaris. A handful of others. The AFL-CIO, I think, has 400,000 members, about 150,000. We also have the Teamsters and the truckers. That's also some like Jimmy Hoffa, mafia related. You have construction unions, but the auto union makes up almost like 30-40% of all union members in America, and most of that is centered in the Northeast, the Rust Belt, and our the tier 1 to final assembly. The automotive I've talked about in the past, like tier 1, tier 2, tier 3. So most of the union companies are final assembly tier 1 suppliers related to the big 3 automakers. And they're decreasing the market share, and the upper middle class, the middle class in America is being hollowed out, and there's a lot of reasons to be favorable to unions. There's a lot of structural problems. So they say, okay, like if you're here, you're educated, you're skilled. Like Dubid is an engineer, like business, trading, selling background. Like everyone here, there might be a handful of people here who started as labor. God forbid people took low birth and started working in a factory and then got a little education or moved up into design and sales. And so, probably like half the people here started blue, started labor, and moved up a little bit into the ranks into sales and design. But the amount of labor jobs has decreased. Michigan, like the mom and pop shop, where I've talked about, like you could conceivably, I think I talked about last year, like the mom and pop manufacturing shop where you have an idea and you make your own part and you mold it and then you buy a machine, where technology has changed in many different ways. There you got the 3D goggles, but the price, the barrier to entry has really risen, where there's very little mom and pop manufacturer left in Michigan. And you also the corporate investment, private equity, where almost all of manufacture is controlled by private equity. So I mentioned like the big 3, the companies themselves are more banks. General Motors, the company, their business is more like bank. If you look at their balance sheets, because they do their own financing when you buy a vehicle, they don't use banks. They have their own banking arm to finance the vehicles. So all of the big three are, the largest component of their model is banking. And then private equity owns the majority of the shares in the company. So the big three and all the major manufacturing, the biggest owner in the company, like Ramp, a lot of these are global companies, they're publicly traded. The biggest owners are private equity. So when you want to do some sort of manufacturing process, it's generally going to go the same. Private equity, funding rounds, not even like taking out a loan. Like at a small level, you could take out a loan, and or like if you started it, at the bottom, so to say, is labor. The chance of you ever entering management is close to zero. Saying like if you start as labor, the amount of money that it takes to buy some of these machines and be competitive would be millions of dollars, and the likelihood is from labor that you would be able to invest in your own machines is close to zero. However, you could take on business partners, private equity. Like you do all the work, someone else makes all the money. And unionization probably wouldn't help in that sense. Like, well, how would unions even help? How could you even change that through unionization? And saying you couldn't, because it's the general structure of our economy right now, the way things are funding, the nature of private equity, that if you had an idea, you would have to take on an investment private equity partner. Your private equity partner would make most of the money and handle part of the business, design, and sales, maybe even engineering practice. So, then you would be stuck running the factory, hiring labor. It would be somewhat zero sum, where if you pay your workers $12, 15 hours, $30 an hour, it's zero sum between that's the money you're making or they're making, and then you have the sales arm. So then you have these conventions, and you're sending people out, for sales or design. So it's tough to actually give some sort of synopsis on a good way forward. Things are moving forward because like technology is moving forward, the science is moving forward, manufacturing is moving forward. There's always money being made. However, the middle class continues to be hollowed out. That there continues to be less demand for jobs, pressure to decrease wages, especially so this show is largely American. I mean, some of these are bigger companies, they're German companies or conglomerates, but as opposed to the battery show and other things, this is almost completely American companies, as opposed to the battery show, which was the minority American companies. So there's the international pressure. Tesla competing in America, but thinking Walter Isaacson's book, the competition coming from Asia and international, just versus labor also. It's a non-unionized plants in the South, Mexico, all forms of international competition. So it's tough to see from the larger economic perspective how this ends up going well, and further divisions between labor and could be labor is going to lose this one to a certain extent. The government might bail out the auto industry. They might the attempt for the electrification. Elon Musk and Tesla could take over the whole electric market. Incompetence. So a lot of people at these shows, they're relatively competent, because this is the engineers' corporate end. So but it's impersonal and unfriendly because the nature of the business side, people want to make sales, they want to monetize their investment. So you have some people okay, let's discuss technology, let's just talk about how the technology works, about science and stuff like that. So most of the people here are science geeks. anyone involved in engineering or manufacturing, you're like, let's just understand how things work in technology and the direction of technology. But at the same time, there's demand. I want to make money. I want to sell my product. I don't want to waste a bunch of time talking to people that aren't going to help me. And I want to be careful with the information that I give over, because information is power, and you have to control the information in a certain way that benefits you. So, if you actually are involved in the process, you can gain from these shows. But like to come here, like for jobs, they're just going to put you into sales or labor, or they like, well, who do you work for? Are you involved in procurement or sales? And so everyone here just wants to sell their product. And you have some of the training, like because if you have the company and you need skilled staff, I mean, there's also an element of labor, holding on to people being trained to operate certain machinery, and the difficulty of maintaining labor. That's the benefit of unions to some extent, is that you have to pay to train the labor before they're useful, and then they could take that training and work for somebody else. So a lot of the people, like, the fun of these shows is that it's like a paid vacation. That the company will pay you to come to the show and learn, network, read the material, go through the conference, the training seminars, in order to make you a better employee. Although, like, then you're in the limited pool where you could just take that free training. You're like, okay, I'm going to get a job at a new company, and they're going to spend a few months training me, well paying me at their own expense. And then you could just leave that company and negotiate a better deal once you're trained. So I'm not saying like, there's probably, it's no easy on any end. And so, God forbid it creates like a little bit of an unfriendly environment at these shows. Although, to a large extent, these shows are my favorite thing. Of like all the things I do, I love coming to these engineering shows. Almost anybody here, I could just walk up, have a conversation, and talk about how things work. Yeah, like everyone here wants to make money. They want to sell a product. They want to know what's your position in what firm, what do you do, are you going to buy something or not? But almost everybody here also, it would be very easy to get into a conversation, just like how are things made, what's the direction of technology, and that's why I come to these shows, gather reading material. But with the UAW strike, one thing also could change the nature. If there's a collapse in, a lot of the reason why these shows are less productive is because of the government meddling into the business, the government picking winners and losers, and because the government is meddled into manufacture, because government funding makes such a huge deal in many things, or regulation in various things, that if the government kind of collapsed, it could reopen up these markets, because the government starts choosing winners and losers, and then it's more like, who do you know, like the woke diversity quotas, feminism, or various aspects that are pushed through larger government grants. Then there's also international competition, and so there's a lot of various issues. So I guess I'm going to sign off. A nice ramble. Pretty good show. If you're here in Michigan, it's going tomorrow also. I'm going to be streaming, I think, with Charles Moskowitz at 8 o'clock tonight, talking about Elon Musk and ADL. But I figured check out the show, gather some reading material, see what's going on. So you can see it's not that big. The battery show was really big. I didn't even have reception, for multiple reasons. One, there's a huge amount of government funding in batteries, so a lot of people are getting paid to come to the battery show. There's a whole bunch of companies where they have government-funded training for these type things, so they pay you to come to the show. So all types of employees at all types of company. Also the direction of technology, especially automotive. So there's a lot of interest. People want to be trained. They want to be in the know. So here, injection molding, really, there's nothing here for you unless you're in the business. So injection molding, like I said, is probably still represents over half of all manufacturing. Injection molding is the single most important thing in the manufacturing process. However, you're not going to come here really and get a job. You're not, going to necessarily find that much information that's going to help you, like in your career, or unless you're already in the business. And the number of the people in the business is relatively pretty small. So this is also a national show. So I mean, people are coming out here from all over the world, mostly America, but some all over the world, and people know what they want. Like, so if you're in the business, you're working in injection molding, you know what you're here for. Like the battery show, it's like, I just want to get a job, I want to find injection technology. There's so much to learn. There's a lot of breakthroughs, like patents, like worldwide. Batteries has one of the most number of patents, like anything. So injection molding, there's also like patents and new discoveries, but not necessarily that much. So I mean, you have 3D printing, molding, scanning, various technologies. You had Molex for the 3D, goggles or manufacturing processes, different computer technologies that have changed in the last few years. Like relatively, there's not many huge advancements in injection molding where like you have to make it to the local, the yearly convention, or you're gonna fall behind in the market. So I guess God bless with that. Signing off. I saw some of the comments, but it's on my cell phone, so they were really too small to read or went across too quickly. So later I'll check out the comments. But anyone's watching, appreciate for tuning in. And week in review this week is Yom Kippur, so there's definitely not going to be a week in review this week. And then Sukkot, I don't know, I might not do another week in review for like 3 weeks. Charles Moskowitz, 8 o'clock tonight. If it's on a link or something, I'll share it on Twitter. With that, signing off. So God bless, and appreciate people tuning in. I'm literally the only one here wearing a mask. God forbid, I don't see a single other person here wearing a mask. But I feel like better safe than sorry. I take care of my mom. My mom has, my mom's already got COVID once, God forbid, and she's vaccinated, like quintuple vaccinated. But God bless. Better safe than sorry. So have a great night.